Hello. Today is Friday, December 7th, 2018. My name is Daniel Mullaney, and behind the camera is Caitlin Yates. Today it is her birthday, and we're happy to have her assistance. We are reviewing a video source inspection of a mask cleaner that was fully refurbished by Cytec. This is a model KNS 971 microwash. This system is equipped to both do wafer cleaning and mask cleaning. The PO number for our customer located in California is 180525-03. Our customer was already on site yesterday to do an on-site review of our equipment, but we are filming this video source inspection for further documentation purposes and reference in the long run. So we're going to begin by taking the camera up to the front of the tool, and we'll explain what you're going to see here on the front panel. You're going to see three gauges here. They have the nitrogen pressure that is going to be higher right now because we're not drying. We're going to have the chuck vacuum, which will pull when the process runs, and we're actually pulling down against the wafer. The mask does not require vacuum, just the wafer. We also have the CO2 reionizer gauge that is going to show the CO2 that is being held for the reionization of the DI water. This is important because DI reionization prevents damage to the mask during the high pressure wash. Here we have the tachometer that shows the RPM of the chuck. Here we have a couple gauges. You can control the speed and the time for your wash cycle, and you can control the speed and the time of your dry cycle. These can be adjusted manually during the process and should be set prior to or during your process setup, prior to any actual product running through the system. Next we have our purge control here. You can purge the line and the pump. This is used to prime the pump prior to any actual processing. We have our typical EMO right here. We have our cycle start button, and we have our wafer release button. Okay, so let's actually now go underneath the system so we can show what we've done here. It's a little bit heavy because this pump is heavy, but so now we're going to show you. Here is what the inside of the mask cleaner looks like. We have some typical gauges here for setting the pressure on the high pressure wash. We have other gauges measuring the facilities. We have a few interlocks here. Most importantly, what we did is we provided a special pump for this job. This pump can handle up to 90 C DI water. Our customer is going to be using 60 C water in order to wash their substrates for specific photoresist removal. We also have a CO2 canister here for the reionization, as I talked about. And then lastly, we have a couple more knobs here for adjusting the nitrogen dry and the wafer release. So this tool, as you can see from the inside, has been fully refurbished. So after I slide back in, I actually need to manually move the canister again. It's very particular about the balance between CO2 and DI water, and when I pull the whole system out, it jostles a little bit. So all I did was pull the canister up and then slowly let it back into its natural position in order to ensure that the interlock is being met properly. So now let's take a look inside our system right here. We're going to have a pretty typical setup for a mask cleaner. We have our chuck right here, which is going to be interchangeable. You'll see we're going to wash both a 3-inch wafer mounted to a 9-inch tape frame, and then after that we're going to change out the chuck and we're going to review a 5-inch mask. We also have our N2 blow-off right here. We have our high pressure oscillating arm right here, and we have our heat lamp right here. So this is a very typical setup for a mask cleaner. Actually, excuse me. The only different part about this mask cleaner is that the pump has been retrofitted to handle the high temp DI water, as well as a few other sets of tubing and fittings. But that is the only difference on this tool. Other than that, is a very standard setup. So one more thing that I'm going to show right here is before running the tool, you're going to want to make sure that the pump is primed properly. So we're going to turn on the flow for the line. I reach underneath, and my fingers are wet now, so that's good. That shows that we have DI water pumping through the line. Now we're going to go ahead and actuate the pump. So that is the high pressure that we've designated for this guy. If we were to look underneath, it's going to be about 2,000 at its max pressure. So we know that this tool is now ready for processing. I'm going to grab a rag real quick here to make sure that all the water is wiped off of our vacuum chuck. Just a little bit sprayed up when we were doing that. Okay, so we got that taken care of. Actually, in this customer circumstance, though, we have the vacuum ports covered over. We got better results in that circumstance, so that's going to be an issue of process for anyone that's using a mask cleaner, is figuring out what works best for you in terms of a lot of things: your spin speed, your pressure, your times. In this case, the vacuum, whether or not it's better to use it or not. For example, masks don't use it, and if you're holding down just a wafer, you'd always want it. In this case, we have a tape frame, so we're getting different results. So I'll go ahead and get this guy installed in here. It's pretty straightforward. It sits in, and then we have a wafer clamp that is now held over it. So really normal here. We will now, yep, that's correct. So we'll now close the chamber here. It moves a little bit slow there because there's a bimba cylinder that holds it a little tight right there. There's also a pin over here that's going to interlock and make sure that the chamber is sealed and the process is working properly. So I'm going to get this guy running now. What you're going to see is this chuck is going to spin at a lower RPM, which will be about 600, 700 RPM, and that's going to be for the oscillating spray arm wash. Following that, our RPM is going to ramp up. I believe our last run was at 2,000 RPM, and that's going to speed up the chuck so that way we can sling more water off and have a faster drying process. So now we're all set. And we're off and running. So right now I can see through here that we have the spray arm oscillating back and forth and pumping. I'm taking a look down at our Haskell pump setting, and we are reaching a maximum PSI of about 2150 or so. And so this is a really straightforward run. In order to adjust, as I mentioned, you could adjust during. I'm not going to change anything now because we've already designed up a process that works well. You can adjust the speed and the time. This being a little bit older piece of equipment, there's not going to be a readout for the time. So you'll have to actually do a manual timing on it if you'd like to document what your actual spec is. That way, if you have to perform any maintenance or you have any questions about how long the time is actually working, say in a couple years, not in a couple years, but over time you have specific PMs to measure that time, that's how you can do it. You can actually take a stopwatch to this guy and perform that PM, really ensuring that your tool is working within the spec that you've designed at the beginning of your process design phase. So now we see it's glowing up here. That's because we are now moving into the dry phase. So the N2 blow-off is blowing the DI water off, and the N2 heat lamp, the heat lamp is turning on and heating up the chamber. Our facility does not have exhaust in this room, so we don't have that drying function working right now. But if there was, when this is installed into a fab, there will be an exhaust hooked up. It'll be about a 150 CFM draw, and that'll really help improve the total dry time on here, especially because it's going to be it's going to be hot DI water in there, so you're going to want to be able to pull out any moisture that's going to, reside in the air itself. So it's looking really good still. The water has shut off a while ago, but the water shut off on the high pressure pump as it's supposed to. You may see a couple drips come out like I just did see. There's no actual purge on that, so that's why the spray arm is going to be off of the chuck itself. So that drip or two that does come through during drying doesn't hit the chuck and doesn't affect your overall result in the end. In a little bit here, we're going to see the heat lamp turn off, and that's how you're going to know that your process is finishing up. as the heat lamp turns off, the chuck doesn't have any actual braking mechanism. It just stops providing power for the spinning, so it'll slow down, which it's doing right now. And so we're already down to about 700, now 500 RPM. And at this moment, the process is actually done. You could open the chamber. So what you want to do is you really want to watch to make sure that the spinning is complete. There's no large hazard here, just because of the design of the tool and what you're doing, but it's always good practice to let the chuck finish spinning and then open the chamber. Actually, I did make a little mistake there. I heard the latch click over, so it sounds like there is an interlock that's looking for that to slow down all the way before it'll let you open the chamber. Okay, so now we're going to go ahead and open this guy up. Okay, and now we have this guy completed right here, nice and dry, and the wafer is completely cleaned. Okay, so now we're going to move on to the next step of our video source inspection, and that is our hardware changeout. So, in order to run a mask, we're going to have to change out the chuck. So what we're going to do here is actually grab that tool right now. Okay, so we'll go ahead first. We're going to take a Phillips in here, and we're going to remove the screws that mount to the initial chuck, or the initial mounting bracket. Okay, looks like I did not complete this screw all the way. I kind of had a hunch that might be the case. All right, you want to make sure that you keep all the screws with the chuck when changing out. The screw lengths on this chuck versus the other chuck are different, so making sure that you have the correct one that stays with the chuck is important. So now we're going to pull on here. Okay. This is the exciting part of the video source inspection. Okay, and so this is the mounting bracket that I described. So this is the mounting bracket for the chuck. The other chuck's going to go ahead and screw right on there. All right. Okay. So now here we have the other chuck. You will set it on. It's a little bit difficult to get it exactly lined up right because you can't spin it once on there because it holds a nice, it holds tight because of the O-ring. So you want to line up the holes ahead of time. There we go. Okay, so I can see down through to the holes. Now you'll notice on this chuck we have the, oh, flick that guy. One moment. Ah, there we go. Okay, these screws are longer. So as you can see with this guy, these screws are longer. So it's important to keep them with this chuck. So go ahead and drop these guys down. And you want to screw these in firm, but not too tight. So we'll go ahead and screw them part way down. Screw until you feel a little bit of resistance. This way we ensure that the chuck is going to sit flat. So you can see the chuck kind of still wobbling back and forth as I tighten each one of these up. Okay, there we go. Let's go back this way a little bit. That one's nice and tight. There we go. There we go. So now by delicately rotating around, we've ensured that we are tight enough to run the process, but we haven't over-tightened and damaged the center hub position. So now we're going to run our mask. Here we have it right here. This is a 5-inch mask. And you may notice that I'm turning this. You're okay to spin this as you go. There's no resistance on it right now. It's actually designed that way so you can have a friendly access to mounting on a different chuck, or actually installing or putting in, I guess you'd say, just the chuck or whatever, or sorry, the mask or whatever else you're running at the time. So now we're going to go ahead and close the chamber. There we go. The process that we're going to be running is going to be identical. Fortunately for mask cleaning and wafer cleaning, one recipe will likely work for all of your different items. It's not a tool that is very has a tight spec on RPM, dry time, everything like that. You know, for example, if you were, say, coating, you need to have a very tight spec on your dispense, as well as your RPM and your time. When you're just scrubbing or high pressure cleaning and drying, it's a lot more friendly on a tolerance to what your spec really is. So now we're running a different item with the same exact recipe. So we'll go ahead and press start. So in addition to providing high-quality refurbished mask cleaners to the semiconductor industry, Cytec specializes in a variety of other tools. First and foremost, that would be the semi-tool spin rinse dryer. We provide 100% of the spare parts and services for the semi-tool spin rinse dryer, as well as the Vertex spin rinse dryer. Cytec recently acquired Martech, which was the current OEM for the Vertex tool set, and now Cytec is the acting OEM for all Vertex equipment. For spare parts and services that we provide for SRDs, we have everything that's required. That means that no matter what part or what service you need to keep your spin rinse dryer up and running, Cytec can provide it. That's windows, door seals, ACR valves, solenoid valves, motors, controllers, amps, tach sensors, rotor stop positioners, anything you need. In addition, we have 100% of the services. So that would be controller repairs, motor repairs, rotor rebalancing, custom polywork, anything that's required. In addition to that, we also have custom parts available for the spin rinse dryer. So if you want to run an odd-shaped substrate, such as a 2¼ inch by 3 inch square glass plate that's 1.5 millimeters thick, and you want a cassette and a rotor to running your spin rinse dryer, we can provide that, as well as the wet bench handling equipment in terms of manual dunking to make that process work for you. All right, now we're moving into the heat stage, just like we did on the last one. So although we specialize in the spin rinse dryer and mask cleaners, and as well HTC box washers such as the Floorware 80, 10, 20, and 30, where we're going to have a variety of spare parts and services, as well as full refurbishments with long warranties, we also can provide refurbished equipment for a variety of other tools. We may not have full spare part and service support for them in the long run, but we can guarantee that your equipment meets OEM spec when it arrives. Such tools would be Nanometrics tools, for the Nanometrics 210, 4000 series, 180s, 181s, 10-core systems such as the 6200 particle counter series, 6400 particle counters, profilometers like the P2, and a variety of others. Some other profilometers like DECTAC. We can also provide resistivity tools such as non-contact M gauges. We can also provide microscopes and YES ovens for vapor prime processing. And lastly, barrel ashers and etchers, such as Branson tools. Those would be typical barrel ash systems. So I kind of jumped around there a little bit on the types of equipment that we sell. I hope that you were able to hear something that interests you as well. But if you did hear anything like that, and you're not there already, please visit our website at www.cytecprocess.com. That's spelled S-I-T-E-K, process.com. And there you'll find our whole product listing. And I'm sure that if you speak with one of our qualified representatives, then you will find what you're looking for. process is complete. Okay, so now we're going to release. And here we are, our perfectly cleaned and dried mask. I'd like to thank you for taking the time to view our video source inspection for today. Again, my name is Daniel Mullaney, and I filmed this video source inspection for SciTech Process Solutions. Again, our company is spelled S-I-T-E-K, Process Solutions, and you can find us on the web by searching for SciTech. Thank you very much, and have a great day.